All right, day 4. We are looking for Xmas. So we get the input, and then we need to find every Xmas, and we need to check horizontal, vertical, and diagonal in all directions. So the way we'll do this is we'll traverse each character, and then if we get an X, we will check in all 8 directions if we see Xmas, and then increase the count by 1. So start by grabbing the test input. Okay, and then we can get the input. We start, as always, by reading the input to a string. So we get the string, and then to get this into a grid, we will just have a list of characters. So grid and data lines, map that, and then we want to get all of the characters from the line, so and collect that into a vec, and then collect the final one. It needs to have an equal sign. All right, so then we have the grid. We are looking for Xmas. So we can loop through each character. So like that, and then each line is equally long, so just like that. And then we need to check if this character is an X. So if grid J is X, then we should do something. So then we want to check in each direction, and we want to check for Xmas. So like we have an X, and then we go X, M, A. That doesn't match. Okay. Then we check another X, M, A. No, it fails. Okay. So we can have the characters and the offset that we're looking for in one variable, and then have the directions in one variable, and we can just loop through them. So we're looking for mass, so I'll just call this mass, and we're looking for mass, right? So first we find the X, and then we find the mass. And if we have characters, and then we enumerate it, we get it. So that's a 0, 1, S. And then, but we want the M to have an offset of 1, not 0. So we'll just map that into this is the index and this is the character. We want it to return I plus 1 and the C and then collect. And we actually want this to be an I size because we're gonna use negative numbers later. So this is now a list of I size and characters. And so then we want to also declare the directions we can go in. If we want all like 3, 4, 5, 6, 7, 8, 9, and so and then negative, and then we should remove this one because it's not moving at all. We just want the 8 directions. So okay, so then we have a list of directions also. So then I'm gonna shadow cast the I and J to I size just because it's easier to work with because we don't have to check overflow like if we have a 0 and go -1. So we can just do that by I, J, and then just have as I size, J as I size. And so then we want to find, we want to loop through each direction, and then we want to loop through each character in the direction. And then we have a count. So we have a count that is 0, and in the end we will print that. So we have delta x, delta y in directions, iterate over that, and then we want to check if all offsets from that in mass is a match with the character. So if mass, iterate over that, then we want to check all, and this has a step and a character. And so then the x will be I plus the delta x, the direction, times the step, and y will be same but for j and y. So then we have x and y. So then we want to check on the grid if that position matches C. However, these are I size, and so we could just check if like if x is less than 0, we can just fail this. But I have a feeling that we're gonna have a lot of these tasks in the 24 days of Advent of Code. And so I want to have a just a method so I can just do a get on a vec with an I size instead of a U size. So I'm gonna create a implementation for that. So like now we have mass get, which returns an option if you send in Y size, and I want to create, so I can just do I get instead and send in an I size instead of a U size. So I'm gonna create an implementation of that, and for vec_t. So function I get, it should take a reference to self, and then an index, and have that be an I size instead of a U size, and it should return an option with a reference to t, just like get does. And then if index is less than 0, we return none. Otherwise, we just return the normal get, but can cast that as to a U size. And so this doesn't compile because you can't do implementation of a foreign type. So the way to fix this is to create a trait. So you can create like my trait and have that here, and then say like you implement this for my tray, something like that, I think. But there's a crate, and I found this out from the Rust subreddit. There's a crate that can just do that automatically with a macro, and just do ext, but you also need to add that, so it's called extend. So you just add that, and yeah. And so what this macro does is just that it creates a trait and do it for this instead. Just saves you some writing of code. Okay, so then here we now can just do a grid. We can do I get and want to x, and then this returns an option, so we can do and then here just have the inner vec I get y, and this should be equal to sum c. Right, and so if this is true, then we will increase count by 1. And so what this does is like if you're used to like C#, like it would be like grid I get x and question mark I get y. That's what and then does. It's apparently called flat map in some languages, according to the documentation. All right, and this should hopefully be correct. Count 18. it should be 18. So then we can grab the real input. And then we get 2,358. And it should be 2,358. All right. Now for part 2. Now instead of looking for X mass, we're looking for an X of mass. And I got stuck on this for like 20 minutes. And I saw on Reddit that other people also got stuck, and they made a meme of it. So this is not okay. It needs to be mass, right? So you can't just count, like find all A's and just count that there's 2 M's and 2 S. You actually need to check that both diagonals are mass, either forwards or backwards. So yeah, it's fun that other people fail in the same way as me. But this is actually I think probably easier. We no longer need this. We no longer need that. So, and now we're not looking for X, we're looking for A. And so now we need to get, like we find all A's, and then we need to check the top left, the top right, the bottom left, and the bottom right, and get those characters as well. And so we just do a big iflet, and sum top left, and then top right, bottom left, bottom right, and this should be equal to grid I get, and this should be top left I minus 1, and then J also minus 1, right? And so top right, it should just be that, and then we have bottoms, and then we have plus here, bottom left, bottom right, and remove the last one of those. Right. Now, of course, we need to check that these are actually MAS, but at least they're not outside or anything. So we can get the first diagonal by checking if top left is M and bottom right is S, or the other way around. So top left is equal to M, and bottom right is equal to S. if this is true, or the other way around. So SM. And then right, we have to do it like that. So we get the values. And then for the other one, we want to check the top right and the bottom left. Top right, bottom left. And then just if both are true, then count can be increased. And then it's 1737. 1737. All right.